Okay, moving on to part two. So in this question, we have a blob of clay, mass little m, thrown horizontally towards a block of mass big M at rest on the floor. And in this case, the two blocks, or the clay and the block, adhere, and they move together a certain distance before they're stopping. We're given the coefficient of friction, and we're asked what the initial speed of the clay was before the collision. So for this problem, we have our givens, right? We're given the two masses. We're given the starting velocity of the big M block, which is 0. We're given that after the collision, they slide a distance of d, and we're given that there's a coefficient of friction, mu. We're also, of course, allowed to use the acceleration due to gravity, lowercase g. What I'm looking for in this problem, I want to find the initial velocity of that clay mass, the little mass. In this question, the two objects, when they collide, they stick together. And that is not an elastic collision. So I won't be able to use conservation of kinetic energy during the collision. That being said, energy is still an essential part to combining momentum and energy to make this solvable. So just like the last problem, this problem is best solved by breaking it down into two parts. We have part one, which would really be the collision of the two objects. And then we have part two, which is the sliding to a stop. And as before, we're going to need both parts of this problem in order to find an answer. The thing that we're looking for here, the initial velocity of the clay, that's actually right at the beginning of part one. So what that implies is there's a good chance that I will have to start at the end of this problem and work backwards in order to find a solution. But we're going to start at the beginning anyway. So for part one, I know that in a collision, best bet is always going to be conservation of momentum. So the initial momentum is going to be equal to the final momentum. Before the collision, the only moving object is the clay. So we'll have the momentum of the clay pre-collision, which will be little m times the initial velocity of that clay. After the collision, we have both objects stuck together. So that's a total mass of m plus big M times the final velocity of m plus big M, the two objects combined. Looking at this V naught M is what I'm trying to solve for. And I know my given values are the masses. So ultimately here, I'm looking for what this final velocity is. As soon as I know that final velocity, I'll be able to solve for the initial velocity of the clay. If I was going to simplify this right now, I would say the initial velocity of the clay, which is what I'm looking for, is going to be equal to m plus big M times v m plus big M all over the mass of the clay. Okay, but I don't have enough information to solve that, right? I have two unknowns here, the initial velocity and the final velocity. So in an elastic collision, I would be setting up an energy equation in order to substitute in there, but this collision's not elastic. It's inelastic. They stick together. So I'm going to have to find my system of equations elsewhere. And so in doing that, I'm going to say what I know about the sliding to a stop. So following the collision, I know that the objects are moving with speed v, so they have kinetic energy, and that there's work being done on them by friction, ultimately leading to them stopping. So my sliding to a stop section, my energy equation might look like this. The kinetic energy after the collision of the two blocks together, plus the work done by friction, is equal to 0, right? That whatever that starting kinetic energy was, plus the work done by friction summed to 0 because it eventually came to rest. That kinetic energy would be 1/2 the sum of the masses times the final velocity of the two masses squared. And then that work done is going to be the force of friction times d equals 0. Now, looking at this, I can already see this v is what I need to simplify for, because then I want to plug it back into my momentum equation and solve for v naught of the clay. Right? So I'm not quite there yet because force of friction is not a variable that I'm allowed to use. So I'm going to have to substitute into that force of friction to get rid of it. This would be 1/2 m plus big M v squared plus force of friction is normal force times mu. But I'm not allowed to use normal force either, so I'll have to simplify this further. 1/2 m plus m v m plus m squared plus, and then the normal force there is going to be the mass times g, the weight of those two objects. So that would be m plus big M times g times mu times d equals 0. And from here, I can solve for that final velocity of the two objects immediately after the collision. Right? So I would get that final velocity of m plus m is equal to the square root of m plus big M times g times mu times d times 2 all over m plus big M. Now that I have that value, I can take it and I'm going to substitute this back in here. And solve for V naught. And that's it. So that's our solution to this next problem. Hooray!